So generally speaking, today we will continue. Those of you who attended the previous session of Victor or my session about data lakes and Hadoop, now we'll see how to take Apache Kafka, Apache Ignite, and GridGain, and to build real-time streaming platform with a scalable in-memory storage for
I'm counting the
business
buzzwords,
needs, right?
like what you forgot, resilient, failure tolerant.
Resilience, fault tolerance, high availability.
Yes.
Speed
In
and
this
scale.
persistence.
Yeah. Durability.
So you probably will enjoy the session. Yeah.
Okay.
So can I ask you a quick question?
No.
So no, I still will. So when I came up to the the venue, I saw the banner that the powering digital enterprise. Like, what's the digital enterprise? So what's the qualities? What the properties of this digital enterprise? And
Yes,
why
so
it's important, like for the in-memory summit specifically?
Yeah, digital enterprise, just two words, right? Nothing important. But if to take at this, from the angle of this topic, digital enterprise kind of sparked the need for real-time streaming, for real-time analytics, especially a lot of the companies, banks, financial.
Can we say that, like in this year, like every company that do business, they have to be on the digital edge of things, because like the way how we interact with our customers these days, the way how we interact with our users these days was online. So this is why I started this, presentation with some like social media things, because everyone online these days, everyone has a phone, and everyone can create their like events that will arrive at our system.
Yeah, absolutely. And all this means what this slide is trying to convey is that queries, right, we have to, like with real-time streaming and memory performance, we have to execute 10 times or 100 times or more queries. The data sets are growing continuously, right? And we have to store 50 times more, 10 times more data, depending on our use case, and process this data. And also you can, I think, support me that now when you are analyzing this data, first of all, it's no longer about operations, right? All of those requirements for hundreds or thousands of queries, more queries, but also for the analytics over the streaming data, over the real-time data. And the solution which we are going to discuss with Victor today, again, we are going to use GridGain as in-memory computing storage as your primary system of records, which goes with in-memory layer and persistence. And for sure, like for streaming analytics, for stream processing, Kafka is one of the best solutions available in the market, and Victor will show us how to enable and to achieve all of those requirements of digital transformation.
I think it's also very important to point out that from perspective not only sizing or from perspective of how we're dealing with data, it's also interesting pattern here is that rise of commercial open source software. Like both the products, GridGain and the Confluent platform, they start as open source foundation. There's like Apache Ignite that drives like an open source community. There's a Apache Kafka that drives open source community. So it's also interesting point when not only software eating the world, like someone said that, I don't remember who, but it sounds like a very smart phrase, but open source software is and lot of things that is happening today is happened on the open source side of things, right? So in this case, like this like a foundational bits, we can also put some foundational slide for the next presentation. All right. So for this talk, I want to start with like small like inspirational idea how the Kafka become a thing. So you start with the building application, right? And we're not stupid people here. We know how to architect application. We know how to deal with the requirements of building things. Here's the problem. Usually technical people very good on building software, building stuff, but they're not very good of communicating things. And these days, software is all about communicating with people, not only with requirements and things like that. So that's why, like, you start building small application. After that, someone also start building small application. Another one starts to building small application. They design this like a very resilient, very highly scalable, And now you need to communicate with your inside your organization, right? You have one service that stores as like a front page of your website. Another service will be responsible for fulfilling orders. Another service will be responsible for dealing with some accounting information, payments, and things like that. You're trying to now integrate these things because your website, we need to call the order fulfillment service, and your website needs to call things like...
It goes out of control, right?
And it goes like this, right? So you start, these links, these communications becomes like almost out of control. Sometimes you do integration through, God forbid, file system and like transferring files. Sometimes you do integration through database. You're sharing database, even though if you're trying to build like a microservices environment, using database as a shared state is not a really good idea, because the database is good for like encapsulating and providing local persistence, but like in this kind of situation, it's just going out of control. You don't know where's the data.
So what are the solutions?
So actually that's not solution. We're changing problem, right? We're changing the problem. So this picture actually came from some of the real world use cases. There's like small social network, another social network that all about like sending your resumes or someone asking you to send a resume. It's called LinkedIn. Like the very small, maybe not very popular here, American social network. And they started with this problem that the portal where we're going to upload our resume or talk to our recruiter, no, I'm not interested in this job, it actually contains multiple services. In these services, one response from the web page needs to be combined responses from multiple places. So they faced this situation back in the day. And they also developed this like small product called Apache Kafka that somehow become popular to solve their own problem, to solve the problem where they didn't have a central neural system, they didn't have a central place where the data will be stored and will be distributed. So that's why the stream platform becomes a center of the things, where everyone can consume, produce data, or listen some of the updates. And the streaming platform, not only, you can say, Victor, it like sounds like a messaging or maybe USB type of thing. Streaming platform also provides capabilities of persisting the data. So you can always return in the past if you're of the processes, lost some of the updates, forget something. So you can always reprocess. So an interesting aspect here that we will also be focusing this, the number of sources and targets for the data also varies, and varies in a very significant, significant form. So we're going to be focusing on the aspect how the streaming platform can deliver data from one sources to another, and also maybe do like a fan out when you have a data from one source and multiple systems want to receive this
So generally speaking, like the architecture we are proposing, this real-time streaming architecture.
Yeah.
We need to have a modern streaming technology, like, and we're going to use Kafka and Confluent today, and also the storage, your backend, also has to be scalable, it has to be kind of performant, etc., etc. So, and like we're going to review like in details now how to build this architecture, and we'll show you a nice demo with some kind of market orders to be generated, and we're going to run some analytics over the data.
Yeah.
So why don't we jump into the details of the Kafka and Confluent? What has to be done?
So the way how we structured this presentation, so we started with this idea that there is lots of devices. Lots of devices, maybe mobile devices, maybe sensors. There's lots of IoT use cases these days, like smart fridges, smart sensors, smart houses, smart homes. I'm getting notifications from my smart homes all the time. So these messages, this data streams through things. And we need to have this high throughput streaming platform that allows to absorb all these messages, because it would be cool that we can process this as it comes, but still it would be nice to not worry about things like a back pressure, where our processor needs to say to our producer who sends us data saying, hey, I'm not following it, hold on. So the Kafka can do this naturally, and allows you to build systems that have this natural property of back pressure. So messages goes into Kafka. Next thing is that we don't want to have another batch processing because it's a new thing. We want to do streaming. We want to do processing in messages as arrive. We want to get answer now, or at least like within 5 minutes. Would be okay. 30 seconds will be okay. You know, when you're trying to get the answer from the system that you expecting result in a matter of seconds, you don't have a time to run the job overnight, right? So you want to get the result computed throughout the data that flows into the system. Now, for that matter, I will be demonstrating some of the KSQL, which is a streaming SQL for Apache Kafka. It's an open source project that we work at the Confluent for a while. It's also on the GitHub. There's another option, so using different tools like a Kafka Streams, which is like a Java library, allows you to write stream processing applications. There's other like stream processing frameworks available, but there will be another slide that explains where KSQL and why SQL is still winning, still alive from all these years. And as a result, so your application that will be dealing with presenting this information to users, presenting information to data analysts, presenting this information to whoever would be interested to get like a reporting style, like analytical style result, will be streamed into this like a so-called serving layer. So this is classical Kappa architecture. So in this case, there's no batches there. It's a classical Kappa, or only a streaming platform and the serving layer that allows fast access to data, where you don't need to think much about how to get this.
Yeah, and also like what's good about this architecture that, let's say you see your data streaming through your Kafka clusters, right? And why KSQL is important here? Because you can analyze data just like as it goes through your pipelines. You don't need to wait while it gets to, let's say, GridGain or Apache. So if you have some of their workloads, if you need to do something like on your raw data, which is coming through the pipelines, just go ahead and use pretty clear and understandable SQL-based language, right? And when it gets into the GridGain cluster or Apache Ignite cluster, that's your final destination, that's your storage. It stores all your data in memory, on disk, and then you can connect your BI tools, you can connect your applications which need to consume this data in real time. Something like which you can do after Kafka pushes this data into the cluster.
Yeah, sometimes a customer asking me like if it's a good idea to store the Kafka data inside the Kafka indefinitely. And the answer usually, as a, you know, having the background as a consultant, usually depends. But in general, it's maybe always the choice on not about can you, but should you. Usually, it's all about storage and how much you're paying for your storage. It was like interesting conversation that we had with our CEO back in the day. He brought this. How many of you have seen this like very cool diagram? It has like a numbers about caches that every engineer needs to know, like and how the latency grows from the cache that deals with the processor cache to the memory, to the disk, to the network, to the cloud, and things like that. You know these numbers and the order of magnitude, how the latency grows. Modern engineer needs to know different numbers. It needs to know how much it costs to run certain computation, regardless if you have like a fast cache, small cache, and things like storages with optimized like access time, like GridGain, allows to use this space efficiently rather than storing this in Kafka. So in this case, Kafka allows you absorbing these messages when they arrive, but for long-term storage, we usually recommend something else, like data lake and like GridGain grid, any type of database or like cold storage that allows to store this data for a while. All right, so this is the premise, and this is what we're trying to demonstrate to you today. So Kafka becomes the central of universe for many organizations. They brought the Kafka into place. When I said center of organization, it doesn't mean that it's just they're running one large cluster. It can be multiple clusters. There's in Kafka community world, we have this trillion messages per day club. It's a number of messages within organization, how much organization like pumping messages. So there's Microsoft, Netflix, and LinkedIn currently three big companies who run Kafka, and they belong to this like trillion message per day club. So it not necessarily means there's one cluster. It can be multiple clusters. It can be like a federated deployment. It can be replicated deployment, like clone deployment, things like that. So it is there. But actual bit that allows to integrate all these components. You can say, okay, Victor, do we need to write all these integrations? Right? Do we need to like how I connect all this system? We don't need to write in other apps. And the best code that you ever write in your life is the code that you don't write. You know?
This configuration.
Yeah.
That kind of
I'm lazy. Yeah, I'm lazy. I'm a lazy engineer. I'm a lazy developer. I always try to, find the easy way because like I need to build demos. I don't build. I build highly scalable Hello World application these days. And the things that I will show you right now, it's called Kafka Connect. It is framework that's a part of Apache Kafka. So Apache Kafka contains three major components. It's the Kafka brokers, Kafka Connect, which is framework that I will be talking about, and the Kafka streams. Kafka covers you from extract data to load data to out of Kafka into transform. So Kafka provides you full-blown ETL 2.0 thing that everyone can use. Now, Kafka Connect allows you to integrate sources and sinks, integrate your source system and your target system. So simplest ways to explain this, there's a standard Java API for producer and consumer, but we call it more like an assembly language for Kafka world. Like you're writing on a very low level, you need to cover multiple things. You need to listen message, you need to transform it, you need to deal serialization, blah, blah, blah. Same with this consumer application. With consumer application, we also need to read the message and know how to process. We need to think about storage, where we need to start an immediate result to process things.
Yeah, and Victor, correct me if I'm wrong, but like this producer and consumer paradigm is something for those who like to code, right?
Yeah.
If you dislike configuration, I'm a sort of the guy when we were preparing to this talk and the demo, we were fighting, like Victor wanted us to make it as configurable as possible, less coding, and I just had a kind of passion,
I code your way through this thing. Yeah, but exactly. So here's example things where you can use producer consumer. If you get paid for number of lines of code that you produce per day, this is the best solution because number of lines of code will be quite significant. If you get paid for delivering results, the consultants versus engineers, right?
Performance review.
You need to switch something else. So Kafka Connect actually already encapsulates producer and consumer bits and jars and all these things. And it also provides some of the runtime when you're simply writing, and we will show you some code. Dennis, we're proud of this code. Yeah. That will actually will be running inside this runtime. So this Kafka connecting will be managing lifecycle of this connector. It will stop connector, provide configuration endpoints, provide the way how it can scale out. You can start multiple instances, and they will form a connect cluster. So you can have multiple, increase the throughput of your production, or if it's a sync connector, you can increase the rate how you can read this data from.
Yeah,
connector.
so here is I can say like for a guy who likes to code, at least I do believe that in most of the scenarios you can omit the coding phase in general, it's Kafka Connect.
Yeah.
But also if you want to write something custom, like some custom Kafka Connect, for instance, today we are going to generate market orders, like market ticks. Some of the stocks are being kind of offered on the market and someone is buying them. And for that stuff, at least, I had fun and I could create kind of my own connector which generates something.
I have a different definition of fun, but
the rest
I will let you have it. Yeah.
But the rest stuff is like automatic and it's like configuration driven.
Yeah, and there's multiple small things that runs inside the connector, and there's still opportunity to code. So even though you already have a connector, you still can have this like small things for doing like a quick transformation SMTs. We call it like a simple message transformations. So you have ability before this message end up in Kafka, you can do some sort of transformation. So usually use case for this kind of situation is that you're dealing with like a cross your data might be belong to the different domains of visibility or like responsibility or regulations. So some of the data might be available in the source system, and the system has the highest level of security, provides all this HIPAA or PII type of compliance requirements. But you need to stream this out without compromising this, or, for example, hardening your Kafka specifically for this. So you can, like, if there is some social security number or some information that comes into the system that is supposed to end up in Kafka, you can use SMTs to do masking. Usually, the number of SMT is already shipped with the Kafka Connect. You can do like a simple regex, but you can do simple things. But you also can code your own SMTs. And another aspect here is the converter. So we will be using this, and we're actually leveraging the converter aspect here. So when the message will arrive into Kafka Connect has its own way how you define the structure of the data. It has a Kafka Connect schema definition. So based on the schema, Kafka Connect can transform the schema into arbitrary format that can be stored inside the Kafka. Usually it's done when you try to standardize something from the source, like you're getting some weird, maybe proprietary format, you want to standardize it, you want to use a converter to change it into the format that all organizations will be using. Or vice versa. We have this some database that supports particular schema, or we not necessarily have a database. We have some I don't know, like full text search system, right?
Yeah, but what's about JSON and Arrow?
Yeah, exactly. So we can use this in the transformers. We're going to be using this Arrow converter that will convert schema of these messages, of these trades that coming from the trading system or whatever system,
from
right?
The market.
Market data. And we'll convert this Arrow because we're going to be using the structured query language to query structural data. So all these things are handled by Kafka Connect framework. So this kind of stuff, if you're starting from scratch, you have to like code your way if you're doing this with producer and consumer. Kafka Connect provides API how to enable, disable certain things. Where to find this? Just Google it. Like for developers, for lazy developers, we have Stack Overflow. For lazy data architects, we have a Confluent Hub. So basically, we decide to build this like an app store for connectors where the people can go and find all possible connectors available. There's different layers of verification. We as a company, we work with the vendors, we went open source community to verify the connectors to make sure that they deliver promise. And all information about the licensing, about documentation, support, all the things available on this Confluent Hub. So if you go there, just like a confluent.io/hub, and you'll find this GridGain, there's connector, and actually you use this to install this connector. There's also CLI that are available to install the connector. Now, let's switch quickly gears before we go into this slide and show how this connector thing works, or you wanna talk about this?
I think that like I would prefer to kind of finish with the theoretical stuff, and then we can just fully switch and focus
let's do it. All right, cool.
On the demo.
So, how many of you here are Java developers? How many of you Scala developers? I didn't catch that.
.NET, C++, .NET, C++, no?
I was preparing some Scala jokes as usual. But okay. So yeah, the thing is the Kafka Streams has a Java and Scala API. There's like idiomatic Scala API. Uses implicit. So I know some implicits, some of the stuff from Scala I know. Do you know what's the difference between, for example, Kotlin and Scala?
What's the first?
So I actually did this test in the field. Like I showed some Kotlin code to Java developers that never seen the code before, and they didn't feel the difference. So, but if you show someone's code in Scala to some other Scala developer, he would also don't understand what is there. Anyway, so the number of developers is high. However, number of people who code their way using different tools, using like a SQL, using different domain-specific languages to process the data is much, much more. It's much, much, much higher. So that's why liberating tools for stream processing for normal people, not like us, for people who actually responsible for doing something with this data, and they don't have a time to figure this out. What's the difference between Kafka streams and Akka streams, for example, right? So there is a way how they can code their way around. So
yes, and basically that's the way is SQL, right? SQL, I hope like you would agree with me that that's a universal language. It doesn't matter what's your programming language, what's your favorite tool, etc. SQL can always give us kind of full access to our data. And with this use case, like with this template of the demo you'll see soon, we decided to focus on SQL. Even though you can use some other kind of APIs like MapReduce, etc., let's just stick to SQL. And the SQL story will start from the top of your pipelines, right, with key SQL. Just write it. Then once the data gets to your distributed storage, to GridGain, later on your BI tools, your applications, etc., they can continue using SQL over the data which is in your distributed cluster, which means that in fact, simplicity, you can reuse your skills you obtained with those previous architectures, right, for the modern architecture.
Yeah, and usually, we already brain damage of the 20 years of SQL, and we already know at least some of the things around it.
Yeah. So and now, let's say we know what's our data. In our case, that would be market ticks. Let's assume we are creating a template for high performance trading use case. The data is coming.
Another buzzword, another bullshit bingo cross. Okay.
Yeah. How many? 5, 6?
Yeah, we're winning. We're definitely winning.
I need to throw out 10 at least. And from the integration standpoint, as Victor has shown, GridGain Connect, right, official Connect, is available for download. So generally speaking, if you would like to use GridGain as a source or as a sink for your streaming platform, then by default you don't need to code anything. You just go ahead, download that Connect, several of kind of commands, you'll see it soon, and you're up and running. Why do we have these kind of dollar bills on the slide? Money.
It's money.
Money is all about honey. So in our use case, right, I had the pleasure to code a little bit.
Yes.
Even though we tried initially to create a configuration-driven use case. In our case, the data source would be our custom Kafka Connect, which generates and emulates market ticks. And after that, all this data will be flowing through Kafka. We are going to analyze this data. And the rightmost piece, well, GridGain is used as a sink. It's all about configuration. We're not going to code everything there. We are just going to start GridGain, deploy Kafka cluster, and kind of amalgamate both frameworks, both tools together with the integration. How it works from GridGain standpoint, why the integration between Kafka Connect and GridGain is high performant and efficient and can be used for those use cases. Because internally, GridGain engineers did all the hard work when they were implementing the integration, and that integration reuses Ignite streaming technologies. Ignite goes with some special APIs which distribute your data across the cluster in the fastest way. So generally speaking, whatever is going to flow from Kafka pipelines into that Kafka Connect, the Kafka Connect internally will arrange all of the packets, all of the data across special kind of network packets, and all of those network packets will be distributed across of your cluster data. For instance, some of the data has to go to one cluster node, the other data will be sent to the other node. And that happens internally, transformatically, which means that the load is balanced, and the same is true for the
essentially this part happens inside this connector. So this is something that already handled, and it's just one of the components that we bring into Connect cluster.
Mm-hmm. And from the API standpoint, right, on this slide, from the application standpoint, applications are going to connect to your distributed storage, to your cluster. And yeah, you can use SQL. In addition to SQL, for sure, you can use other APIs. GridGain, especially for real-time analytics, for analytical use cases, MapReduce, compute tasks, a good tool. The same stays true for machine learning if you need to support of basic classification, regression, etc. But as it was said, today we want to just focus on SQL, not to getting into the details.
Yeah, because as we know from the internet and internet jokes, that writing distributed MapReduce is basically tell someone to write distributed MapReduce joke is just to tell someone just go screw yourself.
So that guy can get his performance review done well, right, and get a raise. All right, so and from the SQL standpoint, again, just really quick, GridGain SQL, it's all about distribute your data in a collocated fashion so that if you have parent-child relationship, it will be handled pretty easily during the data modeling phase. And after that, the data is distributed and we can run complex queries with joins, aggregations, soldering, etc. over that data set, which sits both in memory and on disk. Enough. Let's
do some demos. Okay.
Let's do some demos.
Fire away.
Okay, let me first start GridGain cluster, right?
Okay, yeah.
And ensure that it's up and running, and then we'll deploy some of the connectors.
Yeah.
So that's really quick. And this model, right, today we are running everything from the local laptop.
Yeah. But the cool thing is that everything is containerized these days, and everything is can be deployed in the public clouds or like Kubernetes cluster or whatnot, and all these kind of things. Like from our side, we provide all possible things to run Kafka and Confluent platform whenever you like to run it, including managing service. Like from perspective of GridGain, probably you do the similar thing.
Yeah, now we kind of start small, and that's like a good analogy. When you start with your application, you can have a small cluster of Kafka nodes, GridGain nodes.
Yeah.
Then if you need to scale, it's just all about one more node, one more node.
Yeah.
So like we have the cluster running, we have 2 GridGain nodes on my local laptop, and also I'm going to use GridGain monitoring tool today. So I connected through console.gridgain.com. Here as I can see that those are 2 my nodes running. I've already created special tables, market orders and buyer. There is no any data yet in the market orders. We are going to generate them with Kafka Connect, but there are some of the buyers, some of the guys who are willing to buy
It's
our
called like
stocks.
some reference data or like a master data, like a customer data, right? So
Yeah.
that will be running. So let's start with configuration. Let's show how the configuration of connector look like, and after that you will have your glory to show some of your code. So the idea is to have 2 connectors. One connector will bring data in. This connector will be using Dennis development. And the only thing that we need to specify here is basically what kind of topic, where we need to write this, right? So this is kind of good quality of connectors. Some things are customizable, right? So this is things that outside of the jar that you're providing. So this is why you can always change. Like you can get your own key for this PubNub, the API calls, and this is pretty much it. Number of tasks. This is the declarative specify what's the level of parallelism of connectors you want to have. Again, this is also just configurable, and the connect will handle this. So individual instance of this connector will be running, and there's like a class that's responsible for running this task. Now let's deploy it. So where we are?
Third one in the middle, yeah.
Third one,
no,
second one,
not this,
okay,
this
so cool. We have this Confluent platform up and running for when you're running this Confluent platform locally for one instance, there's no license codes. Like developer version is like free forever. Like all these proprietary things are available for free. And in this case, we're using this very fancy tool called Confluent CLI. That allows to do like multiple things with Kafka, so it knows order of how to start the things. Kafka depends on Zookeeper. Zookeeper starts first. Kafka schema registry depends on Kafka, so Kafka needs to be up and running, so far and so on. So we're building this up. Also, it has nice tools to deploy this connector, so we can do things like we deploy this. So the a command called load will execute a connector. We need to provide the name of connector, and after that we need to provide the properties, the property file that you just showed. So when I run this, it will connect to my local cluster and deploy it, and current, I can get the current status. It's called status. I'm running 2 tasks right now with this the market running 1 task, sorry, with this connector. So also another way how I can see how it's running.
Don't forget to start GridGain sync so that while we are showing the KSQL.
We're not there yet. Yeah, we're not there yet. So the Kafka Connect, you can always see what you have here in the screen. This is when you bring in data in, you will see this is your connector, this is your configuration. Everything that you're putting into this property file can be done from UI. Again, it's all about configuration. It's all about things that you can do from UI. Now, next thing that we need to send data out. Again, we will be using Kafka Connect, and we're using GridGain sync. Configuration-wise, very similar. This connector doesn't require meaning like a build because it's available on the Confluent Hub, so you can get this from there. Again, so this is the topic that it also reads. So as you can see, Kafka allows to perform this like a fan out. We will be using this topic not only for GridGain sync, but also we will be using just for real-time analysis of this data with the Confluent. So send data out, GridGain sync here, same thing, configuration. Always like if you change something, you can do test to verify. Now, data end up in the market data. Let's see if we actually have anything.
Let's run some SQL, right? If you want to.
Yeah. So the data is coming from external system, which is like an API server. So the requests go into space. Through space and time, it goes to this API server, and after that returns back with some of the data. And this is data that we see that flowing through the topic. Data is real time, so it's not going and query the topic, whatever is there. So if there would be no data at the time where we look into this topic, you will not be able to see anything because it erases data as it arrives. So it's kind of like a continuous thing. And the current structure looks like this. We have this the symbol information, order quality, quantity, price, trade, type, and so forth and so on. So data is pretty structured. So we can apply some of the structured data queries. And in order to see the structure, schema, this is also a responsibility of Kafka Connect. It extracts schema and uses Avro converter to extract the schema from the Connect record and put this into Avro format. So this schema can be shared with multiple applications, multiple systems who will be using the same data, and they already have representations, like already agreed about structure. Another cool thing that most importantly, not only people can read the JSON, right? But computers also can read the JSON, can read the schema. So the way how it looks like in this particular case, I can go and say, all right, so go and query this in KSQL. So KSQL, this small server that runs next to the Kafka, KSQL doesn't run inside the Kafka broker, so it's a separate service and can be accessible through the network and so forth and so on. Also read the schema information and infer structure of this stream. Stream is an abstraction that we build on top of topic that allows us to interact with this topic, because topic is a low level like abstraction that we have similar in
it's like
in
would be
database.
our relation, like our table.
Yeah, so we do timestamp is our timestamp for this one, and also we need to specify the message encoded. So the message is Avro format. We select the Avro, KSQL support JSON, and comma separated the text. So let's do something interesting here. Select star from market data, right? So I think this is the most interesting query that everyone typing first.
Yeah, endless data is coming to our system, like we're connected to some public service. It can be Bloomberg, whatever else, and we are consuming, but that's like fake data. It's provided by some other PubNub tool, and we're just
as you can see, I just switched to another screen and my query died. So this case, this query is only running for the session while it's open. So let's do something interesting, and after that we will switch to some persistent stuff. So we know the structure, so we'll do symbol we'll do some like a financial analysis. So is another buzzword for you.
Do you want to copy this one?
Um,
I know that you're lazy.
Okay, let's do copy. So we came prepared. So this case,
I like
Dennis,
that you just,
Dennis doesn't trust.
This guy likes to write SQL queries from scratch, even though you have a template.
So what we have here is that's actually SQL, quite easy to understand, and quite easy to write, but still. So what we're doing here, we probably don't need bit price in this case because it will be more confusing. So what we're doing here, we have this stream of data that comes into our system. We also, on the fly, we want to, for the last 10 seconds, we want to calculate number of the operations that happened, like how many
symbols
orders were placed for where the bids were more than $500, and also this within 10 seconds we want to see maybe like let's do 30 seconds, right?
Yeah, so the primary purpose here that we don't want Kafka streams to update our output every given second or millisecond.
Yeah.
According to our business, it's fine. We want to see that those changes only like once.
So every 30 seconds, it will be new result spit out from out of the stream if it will be compliant with these like a query that we specified, right? So it might be not, but because we might have some of the higher numbers. Okay, so Google within the last 30 seconds there was like 239 operations that involved some of the Google shares, right? Google maybe don't sell the shares anymore. It's an Alphabet. But you got the point. So we will get something, some items here, and also we can do in order to persist this, we can do create a table called I don't know, like the total high rollers. So in this case, when I run this query, it will execute this and get the result immediately. So in this case, it will create a persistent query that I will be able to see here that this particular query is running because this is how I create table. And my table is also appear here, and I can always go in a given moment of time. I can always do things like this, and it will, continue to read this and fulfill this data with this new data. Now, in the last query that we also will do, and this is important, this is query because the same query Dennis will be using in his part. So in this case, we will be getting sums of these operations. We can do from
So yeah,
window,
generally these query answers what are the what are the symbols which are purchased more than the others, right?
So we support the different three types of window. It's a hoping window, a tumbling window, and the session window. So basically, the difference between tumbling and hoping is that like tumbling is just like a fixed amount of time. When the hoping is just they can overlap basically. So tumbling, what's the word I'm looking for? Size. Oops. Size 30. Let's do 10 seconds. So in this case, we will be placing these aggregated sums on the running stream as data arrive in the real time, and we see the total for particular, this window happened 30 seconds, next window, and it's going to be next window for the next 30 seconds, so far and so on. And when we created this persistent query, this also can be materialized as a Kafka topic. If I will go here, you see total high rollers is now persistent topic, so meaning that you can also connect some of the other system. Now let's switch to
let's go to and see like what's going on with our storage, right? While Victor was showing you how to run masterfully KSQL over the data which is flying through your pipelines, let's see like what happened to the GridGain cluster. So it turns out to be that we already have more than 1,000 records, like bits in our system.
While I was talking, someone was working.
Yeah, someone was buying, someone was working, right? And now let's imagine that this application is running for several days, weeks, months, etc. And now if we want to do some more advanced analysis over that historical data, which is both in memory, on disk, etc. So what can we do here? Right, so we can keep using SQL, but now to run it against our GridGain cluster. So for instance, this one is merging data, which is stored in our market purchases, and it tries to find what are their total spendings per our buyer.
So you're doing join, basically.
Yeah,
they're going to favorite question on any conference when you're showing people SQL, someone will ask, can you do join? Can you do join?
Yeah, we can. And like with this analytical use case, I'd like to run this query in real time. And you see that while Kafka is doing something running, this data is keep arriving. And if you want to see these changes over your in-memory data and some historical data, right, just keep running it every millisecond, second, etc., depending on your use case. And here, as you can see, what are the top spenders who are buying most. Probably you would like to go and talk to this guy. Probably he has pretty big wallet, right? And another one, like the same query which was executed over the Kafka streams, but now it's running over your storage.
Yeah.
It's huge data set.
So the difference in this case is that we're running on top of whole data set versus we're running this on the sliding window on top of the data that goes through this through this query.
Yeah. So in this scenario, I just want to see what are the most favorite stocks, right? Ethereum, then Google. So like that's like the current distribution.
Yeah.
That's what we can see. And finally, as long as we have 2 minutes left,
yes.
Let's simulate some
failure. Let's break data center.
Yeah, let's break everything. To do that, here is. First of all, I'm going to kill my GridGain cluster nodes. Also, let me kill Kafka. Why not? I want to kill everything.
Okay, so destroy is a pretty cool command. So it's super useful for development. You're doing something, you play around, you create a bunch of topics, and after that you eventually figure out, okay, I think I screw up my installation of Kafka. Confluent destroy actually remove this like a session that all this like a nonsense that you created, or not nonsense, but at least like something that you were exploring, and you can always start over.
So
don't
like,
use this in production.
Yeah, so no clusters are available, right? And like here is the point of the demonstration. Now let's assume that the data center is recovered, and we have to restart our cluster, our field storage, right?
We will be able to restore in 1 minute.
Yeah, we are restarting the cluster. Right, the first node is up. What's about the second one? It's trying to connect. All right, the cluster is up and running. But the next question, should we preload our data? That's in memory technology, but should we load the data from persistence? No,
you probably need to like rehydrate your cache before that, right?
Yeah, so here is I have all the data in persistence. That's how much space it's already taken. And there is nothing in memory in GridGain.
Can you run this query that you showed with this like a pie chart thing?
Yeah, and now like without any preloading, and that's the importance of like distributed storage.
Don't rush it, because it's going to be your moment to get the applause. So just wait a second. We'll see if we can have the same data back in the system. Run the query. It's there. Yeah. It's awesome. And data is collecting. And
in this case, it was preloaded, served from disk. There was nothing in memory. It was on disk, which means that if you have a downtime, right, for your distributed streaming and in-memory architecture, in memory doesn't mean that you have to wait and preload data of the disk. If you use technologies like GridGain, which goes with both distributed disk layer and in memory layer, you're up and running once your cluster is assembled.
I think it's applause for Dennis. All right, so because we promised the session will last for over 2 hours. So this is where you joining the party and asking questions and makes us to like, okay, so this is nonsense demo and or it's awesome demo. So let us know what you think but plenty of time of advanced interrogation. And we do self again. So I did Instagram. Are you doing Twitter?
say
Yeah, nice. All right. Thank you so much for coming. And again, now you can ask anything you want. We have plenty of time.
Yeah, it's up to you. Like that was the final session for today.
Yeah,
If you want to
yeah.
stay, we want to stay with you. If you want to
Yeah.
go,
This is
go and
what
grab a
this is
beer.
what I call advanced interrogation. So it's where you can ask all your questions about things. Or don't. Yes, please, go ahead.
So when you set up the K-SQL, so it infers the schema. So how it's handling like schema changes? Is it out of scope? So does it just break? Or what if the schema changes? So if you don't have like stable schema.
So if schema changes, each individual message actually has a schema ID. So it will not break your application. Some of the data that what your query was depend on, maybe that is available in new schema, you probably won't see any data because the query doesn't know. So you probably need to resubmit your query if it was like a persistent query that will also understand like a new schema. But it definitely won't break your application. The way how the Avro is working is that there's different readers. There's different Avro handles data for read and for write differently. So you still can write in new version of schema if it's a compatible, like if it's like a forward compatible or backward compatible, and your previous version of application still be able to read the data that this application will depend on. So there's no like automatic schema evolution yet in KSQL. It's a very interesting topic to explore in the future. Yes, please.
What do you need to do to handle the schema drift?
Could you repeat, please?
What would you need to do to handle the schema drift in
In your
your application?
application?
Yes.
Okay. In your application, if it's
we haven't shown the source code, right? If you want, I can quickly.
yes, you can.
Like,
Okay,
let
go
me
do
show,
it.
like,
So
what I did.
essentially, in your application, if it's Java application, you need to do quite a little bit more than in different languages. So first of all, you can go and just query the schema directly from schema registry. Schema registry provides REST API. From this schema, you can actually use for your build tool or for any tooling, like for Maven, for Gradle, or just for command line, you actually can generate your POJOs. But this is not going to be like a regular POJOs because it will also include information about how to serialize, deserialize, and the schema information. So you can use them as a POJOs, but also you can use this with the special serializer, deserializer that comes with Kafka in the Kafka streams. So in this case, you compile this POJO, so you can use this in your design time, like when you compile in your applications. And after that, you can simply share this jar with the rest of the organization who will want to use the same schema. It's just because the Java has these two modes where you do like design time. When you're writing your code, you're compiling the code, you need to have classes, and also you need to have classes when you're running this in runtime. But built-in tools that seamlessly integrate with schema registry, when the Kafka data comes from Kafka, this deserializer will read these bytes and say, okay, so byte number 1 will be responsible for schema version 1. In this case, it will go and retrieve it from schema registry, apply it, deserialize it, and gives you your object. Or another thing. So with this Kafka Connect provides kind of like a generic way to describe your data that goes inside this topic, inside this. So it's called schema. This is not 100% same as an Avro schema, but it's just some schema that defines your object. And after that, this schema can be translated to any format. So by default, it uses Avro converter just to convert the schema into Avro format. Also, you can use JSON converter. It's also just a configuration change. So in this case, this schema will land in Kafka just in a JSON string. This is how you can unify, because as a developer of connector, you know of data structure of your system that you connecting from. So you're getting this information from your system. So that's why you're defining this schema. Same way is on the other side. You get some data from Kafka. You have a converter that reads the data in the format that connector will understand, and after that you can convert this into the schema that GridGain supports.
All right, I think that we need to let The guys go. It's
No,
beer
no,
time.
I promised 2.5 hours. I have plenty of time until my flight. So
Right.
we will hang out here. So if you have any questions, just like come and find me and find Dennis. Thank you so much for being with us. Thank you so much for being
Thanks.
awesome. And enjoy in Memory Compute Summit.